Hi, this is Chris with Sanderson Test Prep, and we are continuing the multiple choice portion of Section 3 Math on SAT Practice Test 1. So here we're going to look at questions 13 through 15. Let's take a look a little more closely at 13. If x is greater than 3, which of the following is equivalent to 1 over x plus 2 plus 1 over x plus 3? Okay. So at first glance, if you look at this and say, yikes, it looks like there's going to be a lot of messy algebra in there, then we've got an alternative for you. If you look at this and you say, hey, I can simplify this algebraically, I'm really comfortable doing that, then that's great. And I'm going to run through the algebra quickly, but I'm going to spend a little bit more time on a strategic approach that makes this question more manageable. So first, let's look at what we would have to do algebraically if we want to approach it in that way. So here, for this expression, first, we'd have to find common denominator, which means you would multiply by whatever's missing. And so here, our denominators of x plus 2 and x plus 3, if we find the product of those, x plus 2 times x plus 3, each individual fraction would be multiplied by what's missing. So here, this 1 would be multiplied by an x plus 3, plus this 1 that's being multiplied by the x plus 2. And then from there, to further simplify, we have 1 over. So this is just going to be x plus 3 plus x plus 2. We can further simplify that in a minute. And then x plus 2 times x plus 3. All right, if we combine like terms, we have 1 over. This would be 2x plus 5. And if we FOIL these two, we would have x squared plus 3x for the outside plus 2x for the inside would be plus 5x, and then plus 6 for those last terms. And now when we're dividing by a fraction, because it's 1 over this whole fraction, we can multiply by the reciprocal. So we would be left with x squared plus 5x plus 6 over 2x plus 5. If we zoom back out and take a glance at our answer choices, we can see that matches answer choice B. So if you're able to do that, great. That's great work, and that's definitely an important skill that we want to utilize on SAT Math. But this is question 13 out of 15, which means it's tough. And for a lot of people, manipulating this algebraically is going to be very difficult. So let's rewind. We're going to erase this, and we're going to see if there's maybe a different strategy we can use to still come up with the same correct answer in a different way. So they say if x is greater than 3, and we can use a strategy that I refer to as PAM, which stands for Pick, Answer, Match. So if you've taken our SAT course, then you're quite familiar with Pick, Answer, Match, and let's walk through how that works here. So first, you're going to pick a number, and you want it to be something easy to work with and something allowed by the question. So they say x is greater than 3, so I might suggest picking 4 or maybe even 5 for something like this. You could pick x equals 217, and that would still work. However, it's going to make the math that you have to do really complex. So we want to try to pick numbers that are easy and allowed by the question. So 4 is the easiest one we could potentially use here. And now we can actually answer the question numerically. So pick, answer. So we're going to answer this numerically. We're going to say, all right, let's see if I plug in my 4. This would be now 1 over 4 plus 2 is 6, plus 1 over 7. And again, we still have to know the fundamental math principles that are underlying the question. So you still have to be able to find common denominator. It's not to say that by using a strategy, it avoids all math knowledge whatsoever, but it does hopefully make something a little bit more concrete to work with numbers rather than to work with variables and algebraic expressions. So here in this case, we can take a look at this, and we can try to find common denominator. So we multiply the left fraction by 7 on top and on bottom, the right fraction by 6 on top and on bottom, and we get 7 over 42 plus 6 over 42, which will give us 1 over 13 over 42. And when you divide by a fraction, it's the same as multiplying by the reciprocal. This gives us 42 over 13. So that's going to be our correct answer here. Now for our last step, what we have to do is we have to try to match one of these answer choices to that fraction. And we want to do this in as few steps as possible. So if I look at this, I say my answer is supposed to come out to be a fraction. Well, C and D aren't fractions, so I might eliminate those without even testing them out. Let's take a look at A and B. If I plug in a 4 for X, I get 2 times 4, which is 8, plus 5, which is 13. So I'm going to get 13 over something, which I can already tell is not what I'm supposed to get. So if I'm being really efficient with how I then go to match the correct answer to the numerical value I came up with, I can already tell it's going to be answer choice B. But just to illustrate that it does in fact work out, if I do 4 squared, that's 16, plus 5 times 4, which is 20. That's 36 plus 6 is 42. If I plug in a 4 into that bottom expression, 2 times 4 is 8, plus 5 is 13, and it all checks out. So PAM is a great strategy. If you see variables in your answer choices in a question that would otherwise ask you to do some complex algebraic manipulation, try using PAM and see if you can work through it a little bit more concretely and numerically. Let's take a look at 14. So here it says 3x minus y equals 12. What is the value of 8 to the x over 2 to the y? So there's a couple different ways that we can approach this, but the most important takeaway here is if you see that you have variables in your exponents, a really good strategy is to try to convert everything so that it's the same base. That way we can apply some of our exponent rules. So here I see I have 2 as a base and 8 as a base. Well, 8's bigger, so let's see if I can break 8 down into something smaller. And especially if we can find something with a base of 2 that could somehow be equal to 8, that's going to allow us to simplify this most effectively. So let's say to ourselves, all right, can I take 2 to a certain exponent and get 8? And what is that exponent? So we're trying to figure out what goes in there. And the exponent on 2, that would give us 8, is going to be 3. 2 to the third power equals 8. And for what it's worth SAT-wise, I do recommend memorizing at least up to 2 to the 6th. We should know really comfortably off the top of our head without having to manually do it, just because those will show up regularly enough. So if they say 2 to the 5th, instead of going, okay, let's start at the beginning, 2 times 2, okay, that's 4 times 2 again, and trying to keep track of it, we should be able to say, oh, 2 to the 5th is 32. And up through 2 to the 6th, which is 64, I think those are really helpful to just memorize because they show up commonly enough that that can be a great time saver. All right, so here we have 2 to the third to the x, and if we simplify that, we multiply that exponent inside and out, so we get this. And then if you have the same base and you're dividing, part of our exponent rules will tell us that we are supposed to subtract those exponents. So this would be the same thing as saying 2 to the 3x minus y, and it's not a coincidence that it works out this way. This expression that they give us at the beginning is exactly what we get here for this exponent. So we know the value of 3x minus y, and we can plug that in. 3x minus y is 12, so this is the same thing as saying 2 to the 12th for that. So here the key takeaway is try to convert everything to the same base. This first step here is really what you want to walk away from this question with in terms of a skill that you can apply on future questions. And the rest of the question down in here, these last couple steps, this part really just comes from knowing your exponent rules to answer this really tough question number 14. Now let's take a look at this last question. And it's question 15, and guess what? It is a doozy, and sometimes you're going to have a question 15, which I will call a true 15, meaning it's as hard as advertised. It's supposed to be the hardest question, and in this case, I think it is in this section. So let's see what we can do. Here we have ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14. For all values of x and a plus b equals 8, what are 2 possible values for c? Okay, so at first glance, there's a lot going on. There's a, b, c, x, there's a couple different expressions. It's looking really complicated, but let's just try and do what we can to see if we can somehow make these two sides of the equation look like each other a little bit. So let's try that out, see what we get. So if you were to just look at this in a vacuum, without the rest of the questions surrounding it, but just two factors times each other, what's that magic word that we think of whenever we see these two binomials times each other like this? So hopefully you look at this and say, oh, that's one of those where I can FOIL it. And that's absolutely what we can do. So let's try that here. It's still going to be complicated. It's going to look a little funny, but let's just try it. So here we have, I'm going to FOIL this down here. So we have A, B. We don't know what those values are. So it's just A times B times x squared. And then our outside terms plus 7ax. Our inside terms plus 2bx. And our last plus 14. Okay, so that's what that looks like if we FOIL it. And it's not perfect, but I'm starting to see that, hey, it looks a little bit like the right side of this equation. I've got an x squared. I've got some x's in here, just like I have an x here. And I've got a 14, just like that. So if I'm setting these equal to each other, let's see if I can start to simplify things and start to brainstorm a way that I can maybe try to answer this question. Again, this question's hard, so if you're looking at this and saying to yourself, you know what, Chris, I think this is way too difficult and not something I would choose to spend my time on test day, and I would jump right into the grid-ins because I know those first few are supposed to be a little easier, then hey, that's a perfect test day strategy, and that's totally okay if that's your approach when you see a question this tough. But let's see if we can at least try to combine a few things here. If I subtract 14 from both sides, those cancel out. And then if I just set the different pieces equal to each other, I'll use some shapes here for this. So, whoops, I don't want to make that look like a negative. It is a positive cx. And then here, let's set these corresponding terms equal to one another. So here, if I have ab times x squared equals 15x squared, and then I have 7ax plus 2bx equals cx. Now I have some things that look a little more manageable. Now I can start trying to cancel out a few things here. abx squared equals 15x squared. They both have an x squared. I can get rid of that. I know that a times b has to equal 15. All right, and then here, every term in this second equation has an x. If I divide everything by x, I know that 7a plus 2b has to equal c. Okay, now I'm getting close, because if I look back at my question, they tell me something about a and b, and they're asking for c, so I do have at least all of those components right here in front of me, so at least I know I'm getting closer. So let's take a look. If a plus b equals 8 and a times b equals 15, well, let's try this out and think of what numbers come to mind. So you could say a plus b equals 8. You might be thinking 4 and 4, but 4 times 4 doesn't equal 15. So let's test out some different options. What times what could equal 15? Well, maybe there's 1 and 15. That doesn't add up to 8. Maybe there's 3 and 5. Oh, there we go. So here, you could say that a is 3 and b is 5. And let's see what would happen if we plugged in a 3 for a and a 5 for b. What kind of value would we get for c? So 21 plus 10 would be 31 for c. Let's see if that's even an option. It is. It's an option right here in answer choice D. Okay, so I'm maybe going to pick that and move on, but where did this 41 come from? How could I have gotten that result? Well, keep in mind, we just picked a is 3 and b is 5 because it worked, but is there another way that those same numbers could work in a different order? And remember, a plus b equals 8. It can go either direction. So you could have said a was 5 and b is 3. And if you did that and plugged it in, well, lo and behold, then that would be 7 times 5 plus 2 times 3, which is 41. And that's how we tackle question 15, which, as I said, is a true 15. Extremely tough question. But up next, we get to ease off a little bit on the difficulty.